Welcome to the deep dive. Today, we're diving into the world of 3D reconstruction. We've got a whole bunch of academic papers and research lined up.
Yeah, it's a fascinating field.
By the end of this deep dive, you'll know how this tech works, how it's evolved, and all the amazing things it can do. Like, seriously, the potential is mind-blowing.
It really is. We're talking applications in everything from engineering and robotics to preserving cultural heritage and even figuring out, like, food volume.
Food volume.
Yeah, like how much space a certain amount of food takes up. It's used in the food industry. But yeah, it's all about taking real-world objects or scenes and creating a digital version, a digital twin almost.
Okay, so it's like taking something from the real world and putting it into the computer.
Right.
But not just like a picture.
No, not a flat image.
As an actual like 3D object, you can like rotate and stuff. But how does that even work? I mean, what are the steps involved in building these digital twins?
Well, think about a photograph. It's flat, right? You can see the colors and textures, but you don't get a sense of how far away things are.
Uh-huh.
That depth information is key to unlocking that third dimension.
So it's like the difference between a painting and a sculpture. You can see the image in a painting, but you can walk around a sculpture and see it from all sides.
Exactly. And with 3D reconstruction, we're basically trying to add that missing depth information.
Okay.
And the cool thing is, there are so many different ways to do this. Some techniques use multiple photos taken from different angles, like photogrammetry.
Okay. I've heard of that.
Others use lasers to measure distances, which is called laser scanning.
Lasers.
And then you've got techniques that project patterns of light onto objects called structured light.
That's what blew my mind when I was reading the research. It's like, whoa, there are so many different ways to capture that depth info.
Yeah, exactly.
Is it like each method has its own pluses and minuses?
You got it. Each technique has its own advantages and disadvantages.
Mm-hmm.
So it really depends on what you're trying to do.
Makes sense.
Photogrammetry, for instance, is great for huge things, like buildings or even entire landscapes. Imagine trying to make a digital model of a whole city.
Wow.
Photogrammetry would be the way to go. On the other hand, laser scanning gives you super accurate measurements.
Oh,
So
yeah.
it's perfect for industrial applications or creating those super detailed models.
So if I'm trying to scan something small and super detailed, like a tiny part for a machine, laser scanning would be the better choice.
Absolutely. Laser scanning is amazing at capturing tiny details. It's so precise. It's used to inspect aircraft engine parts, where even the smallest flaw could be, well, disastrous.
Yeah, that makes sense. So we have all these ways to capture depth information, but how do we actually turn those measurements into a 3D model? Like, how do we build the model?
That's where things get really interesting. One technique called shape from motion, or SFM, really captures the imagination. Yeah, like, a movie special effect where they take a video or a bunch of pictures and extract a 3D model.
Okay, this one I gotta hear more about. How does SFM pull that off? Is it like magic or something?
Well, it might seem like magic, but it's really math and algorithms at work.
Okay.
Imagine you have a video of an object taken from different angles.
Yeah.
The SFM algorithms analyze those images, tracking how features move from one frame to the next. It's kind of similar to how our brains work, actually. You know how we perceive depth by seeing how things shift as we move?
Yeah.
It's like that.
So by tracking how things move in the images, the algorithm can, calculate their position in 3D space.
Exactly. But, just like us, SFM has to deal with real-world issues.
Like what?
Well, think about noisy images, parts of the object being hidden, or even just changing lighting conditions.
Yeah, that makes sense. It's got to be harder than it looks.
Right. So researchers have developed techniques to help SFM, like giving it a way to see through the noise and figure out the true shape.
Cool. So SFM is like using a bunch of snapshots to build up a 3D model.
Yeah, pretty much.
But what about those other techniques, like structured light? That one really intrigued me.
Oh, yeah.
It's like we're painting objects with light to capture their shape. It sounds so futuristic.
Structured light is really cool. Imagine you shine a grid or stripes of light onto an object.
Okay.
Then you use a camera to capture the image.
Yeah.
By analyzing how that light pattern gets distorted by the object's surface, we can figure out its shape.
I can picture that, but how do we go from those distorted light patterns to an actual 3D model?
Triangulation. That geometry concept.
Oh, yeah, like the angles and distances and all that.
Right, you use those to figure out the location of unknown points.
Right, like using a compass and map to figure out where you are.
Exactly. That's what structured light does.
Cool.
The geometry of the projected pattern, whether it's stripes or a grid, is known. So by looking at how that pattern gets distorted, We can use triangulation to pinpoint the 3D location of points on the surface.
Wow, that's awesome. And because we're using light, it can be super precise, right?
Exactly. Structured light can capture those really fine details.
So it would be good for, like, industrial inspections and maybe even medical imaging, right?
Yeah, definitely. But of course, like any tool, structured light has limitations.
I was going to say, there's got to be some things it can't handle.
For example, it can be tricky with super shiny or transparent objects.
Oh, yeah, that makes sense. It's like trying to see through a funhouse mirror with all the reflections. You can't tell what's real.
Exactly. So structured light works best with those matte surfaces.
Got it. So it's not like one technique is perfect for everything. It depends on what you're trying to scan.
That's right. There's no one-size-fits-all solution. The best choice always depends on the specific situation.
That makes sense. This is all so fascinating. So we've talked about using photos, lasers, and even projecting light patterns to capture 3D information.
Yeah.
But what about actually creating the 3D model? How do we go from those measurements to a digital object? Like, what's that process like?
Well, there are some really cool techniques for that. Have you ever heard of voxel coloring and space carving?
Voxel coloring and space carving. Those names sound so cool.
They involve carving a 3D model out of digital space. There's some of the most visually interesting approaches.
Curving a 3D model out of digital space. That sounds straight out of a sci-fi movie. I gotta hear more about this. What are voxels and how does this carving thing actually work?
Okay, so think of voxels as like the 3D version of pixels.
Okay.
They're tiny little cubes that make up the digital space.
Uh-huh.
With voxel coloring, you're basically coloring in the voxels that match what you see in the images you have.
Oh, I see.
The algorithm starts at the back of the object and works its way forward,
Yeah.
making sure that it doesn't include any voxels that are hidden from view.
So it's like filling in a 3D coloring book, but only the parts you can actually see.
Yeah, that's a good way to think about it. And then there's space carving.
Okay. How's that one different?
Space carving is more active. Imagine a sweeping plane that moves through the voxel grid. The algorithm analyzes the images from multiple viewpoints, and as the plane sweeps through, it carves away any voxels that don't match what it sees.
It's like the images are chisels, shaping the model from a block of digital stone.
Exactly.
That's awesome. Both of those techniques sound so cool. So voxel coloring and space curving are really powerful techniques, right?
They are, and as computers get more powerful, they're becoming even more sophisticated.
I bet. This is all incredible. We've covered so much already, from using photos and lasers to capture depth information to carving models out of digital space. But I have a feeling we've only scratched the surface of what's possible with 3D reconstruction.
You're right. This field is constantly evolving. New techniques and applications are popping up all the time. One of the most exciting things, I think, is the rise of mobile devices as powerful 3D scanning tools.
Wait, our phones are turning into 3D scanners. That's insane.
Yeah. It's pretty amazing. There's research showing how we can use phones to make 3D models of objects and scenes, basically putting that 3D scanning power in everyone's pocket.
Wow.
Imagine scanning things for 3D printing, or creating virtual tours of your house, or even using your phone for augmented reality, where digital objects interact with the real world.
The possibilities are endless.
Exactly.
This makes me want to go out and try some 3D scanning with my phone right now. But I guess there must be some challenges in making those complex algorithms work on a phone.
Oh, yeah, definitely. Mobile devices don't have unlimited processing power and memory, but researchers are developing some clever ways to work around that.
Okay, how?
One cool approach uses panoramic images, the kind we all take with our phones already.
Yeah.
And they're using those to build 3D models.
That's brilliant. So we're basically using something that's already on our phones to make 3D scanning more accessible.
Right.
So I guess as our phones get even more powerful, we're going to see even more advanced 3D reconstruction capabilities.
Absolutely. The future of this technology is really exciting, and we're just starting to see what it can do. But, I think we've covered a lot for one session. What do you say we pick up with even more 3D reconstruction goodness in part 2?
Sounds good to me. I can't wait to dive deeper into this tech. It's just so mind-blowing.
Yeah, it really is.
Welcome back to the deep dive. Last time we were talking about all sorts of 3D reconstruction techniques, from those using photos and lasers to those that carve models out of digital voxels.
Yeah.
I was really blown away by how our phones are becoming these powerful 3D scanners.
It's true. The fact that 3D scanning is becoming so accessible is really game-changing. And it's not just about everyday uses.
Right.
3D reconstruction is making a big impact in areas like preserving cultural heritage, too.
That's right. We touched on that a little bit last time, but I'm really interested to learn more.
Yeah.
What are some of the ways that 3D reconstruction is being used to protect and preserve, like, historical artifacts and sites?
Well, think about the challenges involved in preserving really delicate artifacts. I mean, time takes its toll. The elements, even just people touching them, can cause damage.
Yeah, for sure.
3D scanning lets us capture these objects exactly as they are right now,
Right.
creating this digital record of them.
It's like a digital time capsule.
Huh.
And we're not just taking a picture, we're capturing the whole object in 3D. I read about this project where they're using 3D scanning to document the ancient city of Pompeii
Oh, yeah.
before it, like, deteriorates even more from being exposed to the elements.
That's a perfect example.
Yeah.
It shows how 3D reconstruction can be used to document these sites that are at risk of being lost forever. But it goes beyond just individual objects.
Oh, how so?
Imagine creating virtual tours of entire historical sites.
Oh, wow.
That would let people experience them from anywhere in the world.
That's incredible. If people could explore, like, ancient ruins or historical landmarks.
Exactly.
Even if they couldn't physically travel there, it would be like stepping back in time.
And the level of detail you can get with these models is amazing. You could zoom in and see the texture of a mosaic that's centuries old, or examine the brushstrokes on a fresco.
That's amazing.
And then there's the potential for using 3D printing to create replicas
Oh, wow.
of these artifacts.
So we could not only preserve the digital record, but also recreate the objects in the real world. That would open up so many possibilities for museums and education.
Definitely. Students could actually hold a replica of an ancient tool.
Yeah.
Or archaeologists could study a 3D printed model of a delicate fossil.
Wow. It really brings history to life in a whole new way. But let's switch gears a bit. I'd love to hear about another area where 3D reconstruction is having a huge impact. Medical imaging.
Sure.
I mean, we all know about CT scans and MRIs, but how does 3D reconstruction fit into all of that?
Okay, so think about traditional medical imaging.
Yeah.
You often get a bunch of 2D slices of the body.
Okay.
It's like looking at pages in a book. 3D reconstruction allows us to put those pages together to create a complete 3D model of the patient's anatomy.
So instead of just looking at flat images, doctors can see organs and structures in their full 3D complexity.
Exactly.
That must be so valuable for, like, diagnosis and treatment planning.
Absolutely. It gives a much more complete and intuitive understanding of what's going on. For example, surgeons can use these 3D models to plan complicated surgeries,
Wow.
reducing the risks and improving the outcome for the patient.
It's like having a 3D roadmap of the patient's body.
That's a great way to put it.
It's incredible how technology is improving healthcare.
And we're just scratching the surface. 3D reconstruction is also being used to make implants and prosthetics that are specifically designed for the individual.
Oh, wow.
This level of customization is revolutionizing how we approach medicine.
That's amazing. This is all so fascinating. 3D reconstruction is impacting so many fields. It's making history more accessible, improving healthcare, and even letting us hold ancient artifacts in our hands.
Yeah, it really is incredible how 3D reconstruction is changing our interaction with the world, both physically and digitally.
Definitely. And as technology keeps evolving, who knows what amazing applications we'll see in the future.
That's right. The possibilities seem endless.
I'm so excited to see what the future holds, but we've covered a lot of ground already. Maybe we should pause here for now.
Okay.
In part 3, we can delve into some of the more advanced techniques that are shaping the future of 3D reconstruction.
Sounds good to me. I'm looking forward to it.
Welcome back to the deep dive. In the last couple parts, we explored a whole range of 3D reconstruction techniques, from those using photos and lasers to, the ones that carve models out of that digital space. It's amazing how this technology is being used everywhere, preserving cultural heritage, revolutionizing healthcare.
Yeah.
Even just making it so anyone can do 3D scanning with their phone. It's crazy.
It really shows how 3D reconstruction is changing how we see and interact with the world around us.
Mm.
And it's not just about, capturing the physical form of things. It's about understanding them in more detail.
Right.
We can analyze these 3D models, measure them super accurately, even simulate how they would behave in different situations.
As we've been talking about all these applications, it's striking me how 3D reconstruction is almost like giving us superpowers.
Superpowers.
Yeah, we're able to see things in ways that were never possible before.
Oh, yeah.
Capturing all these details and structures that would stayed hidden.
That's a great way to put it.
Right.
It's like we're boosting our perception, extending our senses into the digital world. And then with things like 3D printing, we're blurring the lines between the physical and digital even more.
That's so true. And what's really exciting is how much more accessible this technology is becoming. It's not just stuck in some fancy lab with expensive equipment anymore.
Yeah, exactly.
Like we talked about, mobile devices are becoming these powerful 3D scanners, so the power of 3D reconstruction is literally in people's hands.
I know, right? It's pretty amazing.
This is opening up so much potential for, like, creativity and innovation. I can't wait to see how people use these tools to express themselves, solve problems, like really reshape the world around them.
I'm excited to see what people come up with, too.
So we've talked about the techniques, the applications, how 3D scanning is becoming more accessible to everyone. But what about the future of this technology? What's next? What's coming up that might seem like science fiction today?
Well, one area that's really pushing the boundaries is using AI in 3D reconstruction.
Artificial intelligence.
Yep. AI is making it possible to do things that, like, we never thought we could do.
I mean, AI is everywhere now, from, like, recognizing faces to driving cars.
Exactly.
I'm curious, how is it being used in the world of 3D reconstruction? Can you give some examples?
Well, imagine you feed an AI algorithm a ton of images of objects, and they're matching 3D models. The algorithm can actually learn the relationships between the images and the shapes.
Wow.
So it can then reconstruct new objects from images it's never even seen before.
So it's like we're teaching the AI to see in 3D, just like we do.
Yeah, pretty much. And the results are pretty mind-blowing. Some of these deep learning algorithms, which are a powerful type of AI, can now reconstruct really detailed 3D models from just one image.
Seriously, a single image. That would have sounded crazy just a few years ago. What are some of the applications for this kind of AI-powered 3D reconstruction?
Oh, the possibilities are huge and growing all the time. Think about online shopping, for instance.
Okay.
AI could be used to create 3D models of products from customer photos, so you could, like, try clothes on virtually or even customize things to fit you perfectly.
That would be a game changer. No more guessing how something will look on you or having to deal with returns.
Right.
What about other areas? Are other industries being impacted by this technology?
Absolutely. AI-powered 3D reconstruction is also being used in things like robotics, helping robots understand their environment and interact with objects more effectively. And in healthcare, it can analyze medical images to help with diagnosis and treatment planning.
It sounds like AI is really pushing what's possible with 3D reconstruction, opening up all sorts of new possibilities across so many fields. So for our listeners who are now totally fascinated by all this, like I am, and want to learn more, where should they start?
There are a ton of resources out there. You can search online for some of the keywords we talked about, like structure from motion, space carving, Kinect fusion, or mobile 3D reconstruction. That'll lead you to some really cool articles and research papers.
And for those who like to learn by doing, I'd say just download a 3D scanning app and play around with it. It's actually really easy to create your own 3D models these days.
Oh, definitely. There are also open source software libraries and tons of tutorials online. The main thing is to just experiment, have fun with it, and let your curiosity lead the way. You never know. You might be the one to discover the next big 3D reconstruction application.
I love that. That's a great point to end on. As you explore the world of 3D, think about this. How will 3D scanning being more accessible to everyone change the way we interact with the world physically and digitally?
That's a great question. This technology is already reshaping our reality, and it's only going to become more powerful and more common in the years to come.
That's for sure. Well, thank you so much for joining us on this deep dive into 3D reconstruction. We hope you enjoyed the journey and are feeling inspired to learn even more. Until next time on The Deep Dive.